The molecules of a given mass of gas have RMS velocity 200 meters per second at 27 degrees centigrade. That means at a temperature 27 degrees centigrade, the RMS velocity is equal to 200 meters per second. This 27 degrees centigrade, we need to convert it as a Kelvin, that is plus 273, which is becomes 300 Kelvin. And 1.0 into 10 power of 5 Newton meter is the pressure. When the temperature and the pressure of the gas are respectively 127 degrees centigrade and 0.05 into 10 to the power of 5 Newton meter square, the RMS velocity of its molecule in meters per second is at a temperature 127 degrees centigrade. That means plus 270 is the thing, but 400 Kelvin. What is its RMS velocity we need to find here? Okay, so here we know that change in pressure will not affect the RMS velocity of molecules. So we will calculate only the effect of temperature here. That is, the Vrms is directly proportional to the under root of temperature, that is T. Then V at 300 degree divided by V at 400 degree, we can write it as under root of 300 divided by 400, we can write it as under root of 3 by 4. Then V300 at V300 is equal to V means velocity is equal to 200 meters per second. I'm going to write that one as directly 200 divided by V400 is equal to under root of 3 by 4. This root 4 we can take it as it means 2. That means the under root of 4 is equal to 2. Then we can write this one as V400 is equal to this root 4 will becomes 2 means this 2 will be multiplied here. That is 200 into 2, that is equal to 400 divided by root 3. Then we can write the means final answer is 400 divided by root 3 is the RMS velocity at 400 Kelvin. So option B is the right answer.